Welcome to Spring LIB.
This is the answer to Chapter 31, problem number 16 from the Smith Organic Chemistry textbook. And this problem tells us that polyethylene terephthalate, which is PET, is also prepared by the transesterification of dimethyl terephthalate with ethylene glycol. And we're asked to draw the mechanism for this reaction. And so this mechanism can be found in the carboxylic acid derivatives chapter. So this is just a nucleophilic substitution on an ester. So we're starting with dimethyl terephthalate, and we're just going to transesterify it with the ethylene glycol under acidic conditions, and then that's just going to repeat over and over and over again. So for purposes of saving time and space, I'm just going to abbreviate the majority of the dimethyl terephthalate with pH, and so essentially all the action is going to take place here at the methyl esters. Okay, and so that's a molecule of dimethyl terephthalate. So we're told that this reaction takes place with an acid catalyst or under acidic conditions. So I'm just going to use H+. You could use H3O+. It doesn't really matter. The first thing that's going to happen is the carbonyl oxygen is going to grab that acidic proton. So remember, for a transesterification, or really for any carboxylic acid derivative hydrolysis that's taking place under acidic conditions, the first thing that needs to happen is that the carbonyl oxygen needs to be protonated. So that gets us to here with that oxygen protonated. It's also going to have a positive charge because it now has 3 bonds. And hopefully everybody remembers that in turn makes the carbonyl carbon much more susceptible to nucleophilic attack. And so that's what's going to happen. So here we have our nucleophile in the form of one of the alcohols on the ethylene glycol. So a lone pair from one of these oxygens is going to attack the carbonyl carbon. The electrons of one of the double bonds will kick up. And so now we have our tetrahedral intermediate, which is, of course, a key part of all of these carbonyl reactions. This oxygen, the oxygen that was just the nucleophile, now has 3 bonds. So it's also going to have a positive charge. I guess not also, it's going to have a positive charge now. And so the next step is going to be to relieve that positive charge. So we have our acid catalyst, so it's safe to assume that there's some water floating around in here. And so the oxygen of the water, one of the lone pairs, can grab that hydrogen. Those electrons can go to the oxygen that had the charge on it, relieving the charge. So we are now to this point where we have our tetrahedral intermediate with no charge on it, no charge in it. So there we go. There's the tetrahedral intermediate there. And so the next thing that needs to happen is we need to reform the carbonyl here, reform the ester. And so we want to protonate the correct oxygen. So there's still acid floating around in here. And so the oxygen that was formerly part of the ester is the one that we want to leave. So that one will grab an acidic proton and become charged. And I guess really, to be correct, these steps are all happening in equilibrium. So we should include the back and forth arrows. So we'll protonate that one, as I said. And of course, since that oxygen now has 3 bonds, it's going to have a plus charge as well. And it's now a good leaving group, which is the point of protonating it. And so it's going to leave. At the same time, we can show this oxygen that's an alcohol currently reforming this carbonyl here. So it now has a plus charge, positive charge. And so lastly, the last step of this mechanism to complete the transesterification is going to be another molecule of water floating on by and grabbing that hydrogen. Those electrons will go to that oxygen. And so now we have successfully transesterified our starting dimethyl terephthalate. Okay, and so I'm going to just draw the whole product just to make sure that everyone's aware what we're talking about here. So this, what I've drawn right here, is what I had substituted with the CH3 before. Or I apologize. This is what I substituted with the pH before. So the whole product looks like this. And so in order to get from this to the polymer, basically we just need the reaction that we drew to happen the exact same way at this carbonyl. And then we have these alcohols that are still available to act as a nucleophile on a carbonyl of a neighboring dimethyl terephthalate. And so a sequence of these reactions happening over and over again is going to give us our polymer chain. And so that's the answer to chapter 31, problem number 16.